Hi, everyone. My name is Renato Losio, and I'm a cloud architect. I work as a principal cloud architect at Funamball, and I'm editor InfoQ, and I'm somehow a AWS data hero. And today I would like to talk to you about cost optimization on the cloud. So without further ado, let's start to share my slides. Okay. So today we talk about money. Money from a developer, money from a software architect, from a DevOps point of view. We are not talking about how to optimize your cloud deployment, your cost from a CFO point of view or from a business point of view, but more from a technical point of view. Which kind of pattern can help us? Which kind of pattern can make us, what can create problem to us? So when we think about AWS, we are talking about 214 different services, almost 2,000 different, each one of them has different price component, talking about almost 2,000 price component. And if you're lucky enough that you're old enough that you started about 10 years ago, probably life was easy. I mean, there were a few basic services, and the choice was usually not that hard, both in terms of architecture and in terms of cost optimization. If S3 has just a couple of storage classes, it was quite easy to decide which one was good for you. When you have more than two and you have different services covering the same area, it's a bit harder. By the way, I made these numbers up. I have no idea how many services are available now, but the order of magnitude is more or less that one. So as a developer, how can you really have take care of that? Well, there's even a blog. AWS has a cost management blog that offers you some advice how to optimize your cost and how to monitor your cost almost. This is a post from early this year, just a few months ago. It doesn't matter if you use the firewall, so Advanced Shield or whatever else. The key point here is it gives you an idea how complicated life is. Basically, Amazon tells you to monitor the cost of one service, that is your firewall. Well, please use a different service, Athena, and run a specific query. And how complicated is that? So, of course, you're going to pay for that one as well. I'm not making a joke of AWS. Actually, what they are suggesting makes a lot of sense. But to give you the idea of complexity is what Amazon is suggesting you to monitor the cost, to estimate your cost of the Shield Advancer from the firewall, you have to run this kind of query. So that already gives you the idea of how complicated it is to go really down in determining the cost of what you're running. Now, even what a component in the cost is sometimes quite tricky to figure out. Everyone tells you how a cloud provider is better than the other one, how something is cheaper on one provider than the other one, why. But usually you compare just storage, CPU. Sometimes you are even able to compare data transfer. But for example, let's think about a very basic service like the load balancer. One of the key metrics is the you pay by traffic, and the traffic is charged by LCU. What is a LCU? And is that $0.008 per LCU hour a lot or a little? Well, it really depends, because a LCU is determined by 4 different components: the connection, the active connection, the process by, the rule evaluation, and there's a certain amount of free rules. And only one of these components is going to affect you. So if you have a lot of binary data transfer, probably the process bias, but not always. But the point here is not straightforward up front to determine the cost. So you really need to monitor. And I usually don't trust too much people that tells you in advance without knowing anything how much you're going to spend on your deployment. Because yes, maybe you're able to determine how much is the cost, the fixed cost of the load balancer of the EC2, but the cost of data transfer or the cost of the process data of the load balancer, well, is a bit more complicated than that. In this presentation, we are not going to we say we are going to talk it from a developer point of view. And we are going to try to do things as give suggestions that we can address in one iteration, a couple of iterations. So things you can address in hours, developer hours, or days, eventually weeks. but not things you can address in months or years. I'm not talking about moving to a different cloud provider or changing entirely your architecture. Because, well, usually as well is out of scope for a developer. I mean, there are topics that we are not going to cover because as a developer, you have no control or you have very limited control. Of course, there are things that can help a lot and you should, as a company, you should take care of, like multi-cloud, multi-migration between different clouds if you have better deals on another provider, or something as simple as reserve capacity, reserve instances, saving plans are all great things, but usually it's not the developer that choose that because there are some business commitment on that sense. Even discount, if you are a large customer with Amazon, you might have a private pricing. That's cool. If you have ADP, it's great, but that's not something as a developer I'm going to control. We're not going to cover for the very same reason credits. So if you are a startup, you might apply to different startup program, whatever is active program, whatever, and get credits. Again, out of scope. It makes a lot of sense to apply and ask for it, but that's not something that is going to save your cloud bill from a developer point of view. Two other things we're not going to cover. We're not going to cover significant different price in different regions because, again, usually you have a deployment in one region. Moving to a different region has some cost, and usually as well there's some data compliance. It might be, again, out of scope for you. You cannot control that. And two other topics we're not going to address, but they are usually quite important, is vendor lock-in, because usually some choices you make to reduce your cost might increase the coupling between your deployment and the cloud provider. So it's something to keep in mind as a business. And the other one is spot instances, because they are a very specific topic. There are many use cases where it makes a lot of sense. There are great presentations out there. It takes 1 hour just to talk about how to optimize spot instances. So again, we consider that out of scope today. So very first thing you have to do if you want to take care of your cloud deployment and really do cost optimization and find out what best pattern you can have and which one you're not following and which actually pattern are backfiring in your deployment is you need to enable bill and cost management. Sounds crazy, but by default, only root has access to that. Developer usually doesn't have that. Ask for it. In most cases, you should be able to have access to it, because if you are not able, I'm not saying just see the PDF at the end of the month with the cost. You really need to be able to access any metric that Amazon explores in terms of cost. So that dashboard should be your main focus. A second tool that it doesn't really help in reducing cost, but can help you in monitoring cost is something quite new from a few months ago. Please go and enable it. Is anomaly detection. Was announced in preview last September. Is now general available. It's free. It triggers by machine learning any significant change. You can put some threshold if you want on your deployment. If cost spikes up, it doesn't trigger if costs go down, but it helps you. If we're going to apply some changes to the deployment to improve it, as we see in a second, you want to have some safety net that if what you did and what you assume is not going to be true, well, that if a new cost component is going to spike in the next few days, at least you are alerted. So go enable it and get notified. Now, key point of this presentation, key point before applying the changes. We need to be able to measure what we do. Usually Amazon talks a lot about tagging. Yeah, there's really a lot of point in tagging, because you need to be able with, in the cost component, you're able to then, if you enable a specific tag on something you're migrating or something you're doing, can really help a lot to measure it. So try to be sensible, think what you're going to try to address, but tagging can be one option, is usually a comfortable one. Just always think when you want to address one of the changes you're going to do is how you're going to measure how much it costs before and how much it's going to cost after. Because at the end, you're going to spend your iteration, your days on that change is quite significant if that change brings a lot of saving or it brings $3 a month or even backfires. Why I'm saying that? Because you might think it's easy to estimate, but that usually is not. Because, well, this is a comment from Airbnb from a post quite recent. There's a link at the end of the presentation where actually they say that from that point of view, early 2021, the most viewed dashboard of the Airbnb that is a heavy AWS customer is the dashboard of the AWS cost. So monitoring is the key. So let's take an example. You may say, well, I'm really, really good in monitoring. I can guess if what I'm changing is going to bring money, is going to bring value. Well, be careful with that, because if you are in a successful project, or hopefully you're working on a successful project, usually, even if you optimize, costs tend to go up. Let's take a fake example. Let's say that I have a billing that is $38,000 in November, and it goes up about 5% a month for the foreseeable future. That's a growing project. Now, first of all, notice that as services have a different price strategy, it might be that the way it grows is not linear. So, for example, there are services that you pay per month. So S3, you pay gigabyte per month. Other services that you pay by second or by hour. So, for example, a month of 28 days of February versus a month of 31 January, it might have a growth that is different, because some components you still pay by month, like support, other that you pay by hour or whatever, or by traffic or whatever. So it might really change the percentage you go up. But let's assume you have that growth of around 5%. Now, you apply, we are in middle of December, you say, oh, I saw the reInvent, I have a cool new feature I'm going to apply, I'm going to change, I don't know, we'll see in a second, I'm going to change the storage class for my EBS volumes. And that change is going to apply, it's going to be a successful one. I'm going to reduce already in December, I'm going to make my bill quite lower. And you can see in the second line, when I applied that change, that compared to the previous deployment, I'm able to say that from February on, I have a recurrent saving of over $1,000. That's great. You almost have a pay rise for that. Now, the problem is, if you are not monitoring how will be the cost in the two scenario, if you just see the second line that goes from 38,000 to 44,000, well, would you really expect that someone outside your development team is going to see that change, or is going to even appreciate what you did? Because at the end, the costs are still going up. It's just going up with a different rate. So try always to keep in mind that you need to be able to measure what you're going to change. Now, what suggestion we can have, what pattern we are going to see now? There are three major areas. I would say we see things in compute, we see things in storage, and we see things in data transfer. Now, you might have a deployment where you're using something else. I mean, of course, if the only service you use on AWS is, I don't know, a data warehouse, you're using Redshift, and everything else is Autoscope, well, most of those suggestions are not going to help a bit. But in most cases, most deployment, I will say that compute, storage, and data transfer are the main area where you're going to do your saving. So try to concentrate on this area. So look at your bill, see where the major areas are, and start from there. So few suggestions in terms of compute. Avoid any fixed IP whenever you can. Now, I'm not talking about allocate Elastic IP and not use it. That is going to cost you probably $5-7 a month. That's not what I'm talking about. You might have a good reason actually to allocate an IP and keep it as spare pool capacity. What I'm talking is try to architect in a way that you don't need fixed IP in the first place. Because think about a simple example. Think about you want to use a load balancer and you need, you decide, oh, I want to have fixed IP because I want to have, I don't know, there's a requirement from my customer, or I decide that I prefer to have fixed static IP on the front end because I can monitor my traffic or zero rating or whatever I'm going to do. Can I do static IPs on an application load balancer in Amazon? Well, not directly. Amazon, this is a post from Amazon, suggests different ways to achieve it. You can do it, for example, putting a network load balancer in front of your application load balancer, and the network load balancer can have at that point the fixed IPs, or now they suggest you can use the global accelerator. It's great. You have a static IP in front of your load balancer, and you can do it in a couple of minutes. It's true, you can do it in a couple of minutes. I'm not working for Amazon, but seriously, you can put a global accelerator in front of your load balancer really in a couple of minutes with one API call. And it's straightforward to monitor and do anything else. The problem is now you're paying or for two load balancer and the data traffic through two load balancer with the network load balancer and the application load balancer, or you're going to pay for the global accelerator. How much does the global accelerator cost? Well, who knows, because it really depends where your user base, where does the user connect from. The price component becomes, for sure, you're going to have an extra component, and it gets much more difficult to monitor. So fixed IP, if you can avoid them, get rid of them. Second one, more generic, is go Graviton. Amazon is really, really pushing to get away from Intel machine, go to their new Graviton 2 instances, mainly MC, M6G, but as well, there are now many services that are not even anymore EC2, but managed service like Elastic Cache or Amazon RDS for database, where you can just use Graviton instances. And Amazon claim you can have 52 better price performance. That means it costs about 20% less and you get better performances. Maybe that's a bit optimistic. That's told by Amazon, but that's a post belonged by Percona testing a Postgres on a Graviton instance, M5 4 extra large, if I well remember, or 16 extra large versus the corresponding M6. Is it any good? I'm going to spoil the result. At the end of the day, they say, yes, it's really good. You're probably not 52% better, but you're going to save double digits. 20, 30% is easy to achieve. And in the case of managed service, well, if you use EC2 instance, you need to use different packages. You might have many dependencies. With managed service, maybe the only dependency is the version. So for example, this for Graviton instances on RDS only for MySQL 8, not the 5.7, or limitation like that one. So apart from that, I really like the Center for Coroquin is, yeah, it's cool that they tell you what they run behind. You're using a managed service, you don't care. So if the ARM, if Graviton instance is cheaper, the Intel, go for it. Okay, instead of going for the very latest idea in technology, go the opposite way. What? I'm really saying for the Lightsail is a very simple service that is quite not well known in the AWS world, for me at least, that covers many simple use cases. What is Lightsail? Lightsail is something old. It's an old concept that was there before the cloud, that is a hosting provider providing you some virtual private server for a low predictable price. So you get an instance, you say, okay, I want a small one that you don't have to decide upfront how much storage I'm going to attach, which kind of data traffic I'm going to do. It's just a fixed price per month. So like whatever is $3, $5, $10, $50 a month. And yeah, it usually applies to a very simple scenario. You might want to use it if you, I don't know, move your WordPress to AWS, but you can actually use it in many scenarios where you don't really need all the complexity of a full deployment of a VPC almost all at the beginning. And our company, this is a post, for example, they show that they were really able to reduce their cost on AWS thanks to simply going Lightsail. And Lightsail now introduces as well container, managed databases. And of course, you cannot compare like for like, but at the same time, like if the corresponding Lightsail instance that you pay $20 as an EC2 instance with the corresponding characteristic, where of course you have much more flexibility, is much more expensive, it's almost double price. Same, there are many cases where the Lightsail database with a bit of backup and whatever is enough instead of using a multi-AZ RDS that costs significantly more. So that's an option. It doesn't apply, of course, in every deployment, but it's something that many people don't consider, but there's a scope as well for Lightsail. Now, data transfer. Data transfer is the area that usually is most neglected because it's pretty hard to figure it out. And the main problem is really depends where the data is coming from, where the data is going to, which service is involved. This is a nice slide from the last week in AWS blog that was quite popular last year and show how complex the concept of data transfer is. But there are a few basic concepts out there. First one is usually data traffic in towards the cloud. So the data that you send to the cloud is kind of a vendor lock-in. It's free. You don't pay if you send data to AWS. You don't pay data you send to Google Cloud or whatever. You pay when you take the data out. And that's okay. That's the easy part. Then you have some cost associated, for example, to if you transfer data between regions, and the cost is slightly different. It depends on the region as well. And you have as well a cost associated between moving data between zones. That means that when you do in multi-AZ, you have to remember that data between zones has a price component. And as well, managed services might remove some of those costs. So comparing a database, for example, running, say, I run my MySQL as a multi-AZ RDS versus I compare running my database as a my own deployment on EC2 with a master and primary, so basically a primary node and a replica, and I do my own failover, we have to remember that that's the transfer between the two zones, that you're going to pay and you don't pay with a managed service. Basic rules are try to stay away from anything like a NAT gateway, and if you have to use a NAT gateway where you pay a crazy amount by gigabyte, make sure you use VPC endpoint, because without VPC endpoint on S3 are going to save you a lot of the traffic. Otherwise, if you have a lot of traffic going between your cluster and S3, if you don't use any VPC endpoint and you have, for example, a NAT instance, all your traffic is going through the NAT instance, even if it's going between two AWS services. The fact that it's going between two AWS services doesn't mean that it's not going through a public network. So, few notes here. Multi-AZ is always better. Well, one of the common patterns on AWS is you learn it on any certification, learning from day one is always deploying multiple AZ because, well, if AZ is lost, you don't lose your traffic. That's great, it's true. How often that happens is something you have to do in your risk management assessment. And of course, the more zone you use, the less percentage you lose of your cluster, of your deployment, of your capacity when something goes wrong the AWS side. But keep in mind that you always have to consider that if you have a lot of data traffic between the AZ, that's the component you have to consider. So if you have a lot of data traffic between different AZ, not through managed service, maybe it's better to deploy the entire solution in different AZ. So if you have, I don't know, a queue that process some binary files, some FFmpeg file or whatever, maybe it's cheaper to have two deployments in two AZ than have a single one moving data across the different zones. The same about multi-region. Yes, multi-region as a strategy, backup strategy is great. I mean, of course, there are scenarios where it makes a lot of sense, but the problem is, it's now too easy. I mean, you can just call an API or just go on the console, click a couple of buttons and do a replica of your database on the other side of the world instead of doing the same region. Does it make sense? Well, there are scenarios where it makes a lot of sense, but make sure that you're in one of those and you're not simply doing it because it's possible, because the cost associated with it might be much more significant than what you really are forecasting there. Multi-cloud. Well, multi-cloud deserves its own presentation, but generally always think about all the components involved. It's not simply replacing a piece. It might be that if you go in a multi-cloud scenario, you might be better in really changing the logic of your application. Let's do an example. The world is full of S3-like deployment, S3-like services. So let's take this example, Backblaze. They tell you can save 75% of your storage on whatever is true or not, doesn't really matter for the point of representation. The point is, you have to think that the moment you put a second component outside your cloud provider, so if you use storage on Azure, or if you use a S3-like component or whatever else, now suddenly when you upload your data to your cluster on Amazon, and then your EC2 or your container is uploading the binary to S3 or to S3-like, the entire data transfer model changes. Because basically, it's not anymore ingression data. It's not for free. You're not sending the data to Amazon, and then you are not paying the data traffic in, apart from, of course, the traffic through the load balancer. You're now sending the data from Amazon to this third party, and that's a component you have to really evaluate to decide if that's worth. The same when you take data out, is not anymore data. You pay the data transfer out from that provider as well. So, for example, it might be worth that then the upload is done, depending on the encryption key or whatever, if it's client encrypted or whatever, done straight with the on the third-party provider and not through the load balancer, for example, or not through S3. So, basic rule here is if you add a third-party component, don't just assume that because you are reducing the storage cost, you're going to increase the complexity, and it's not obvious that you're going to reduce your overall cost. CDN. So there are many scenarios where you really don't need CDN, so CloudFront. You might be happy to just use a load balancer. Now, the problem is that there are scenario where it's actually cheaper just to use CloudFront for a couple of reasons. Is that CloudFront has now as well his own, apart from his own private pricing that you can have if you're a large company, but as well, there are now what they call security saving bundles. So you can pre-commit basically some traffic on the CloudFront distribution that makes cheaper to run your website through a CloudFront distribution, even if you are actually using no caching, if you forward any request to the load balancer behind. That's enough for data transfer. So let's talk about storage. Well, the problem with storage it really depends. Cold storage, frozen, hot, chaos, whatever it is. You can handle storage in very different ways. If you were lucky enough to work on S3 10 years ago, you had just basically two options: standard storage or what at that point was called reduced redundancy. So it was quite obvious what option you had and where to store and how to store your storage on S3. Now it's a bit more complex because now there are, at least as for today, 6 different storage classes plus the whole reduced redundancies that is out of scope. All of them are designed with the same durability of data, so 11 nines. That's cool. They have a different availability, and with one exception, that they are the one zone infrequent access. We see in a second. We keep there are at least 3 different AZ involved, so 6 copies of the data in 3 different data centers. The problem is that apart from the standard storage, all the other ones have a minimum commitment in object capacity and a minimum duration charge. So a minimum time the data is going to be charged regardless of what you do. So if you put a data as S3 standard infrequent access and you delete after 1 day, you still pay for 30 days of it. Same as well, you pay some retrieval fee for any gigabyte retrieve of the other. So it really gives you a lot of flexibility, a lot of way to saving, but as well a lot of complexity behind. So for example, what does it mean, the S3 one zone infrequent access? They tell you with that little asterisk, well, we have the same copy, the same even the same availability, same durability. Well, yes, all very true, but then they tell you, well, if we lose the entire availability zone, in terms of availability zone destruction, whether it's a earthquake, a fire, or whatever, your data might be lost. So it might be really good for data that is backed up from local storage in your own data center, or for process data. If you do, I don't know, media transcoding, maybe you want to save it that way because you still have the original file. Is there really a likelihood that something can happen? Well, what is a AZ destruction, first of all? Should I care as a developer? Well, you might want to care. This is earlier this year, actually, in March, that, if you lose a data center, you might lose your data. So, there are scenarios where it's worth to keep all the data in a single data center for AWS, but that's not the default, and there are very few use cases where that makes sense as a saving plan. Okay, so you say, okay, it's too complex. That's really something that they call you intelligent here. So why should I not use that one? They do the logic for me. You go back here, that's the table. They tell you, well, you don't pay for retrieval fee. They do the logic themselves. There's no minimum capacity per object. They do the logic. Well, the problem is they do the logic with a high level visibility. So you'll be charged the frequent access rate for any object under 128 kilobyte. That's the first problem. And that's true, is the minimum charge you're going to be charging the standard infrequent access, but that's not really the minimum charge for a standard infrequent access object. So basically, an object that is 100K is still cheaper as a standard infrequent access than as a standard object if kept for at least 30 days. Moreover, there's a fee associated with the intelligent class. And that depends on the number of objects. So if that makes sense for you, it really depends on how many objects versus storage you have. So if you have a lot of few very large objects, so if you have petabyte of data made by terabyte objects that are gigabyte, terabyte in average, that's no question, it's very simple to decide that. But if you have a lot of small files, well, that's not really that obvious how you're going to address that. But the key point as a developer to think is how you're going to distribute the objects in your bucket because it's going to be hard and costly to move them, is key to decide any cost optimization strategy. The reason is, in the past, used to be the concept, let's distribute the objects in the most distributed way, because that's the way that very high capacity S3 scales better. That was true, it's not entirely true anymore. The key point is you need to make sure that you have a way to access those objects for lifecycle rules. What are lifecycle rules? Well, you can change the object class yourself, going to change every object, making the request. But if you have a bucket in production with billion of objects, that's not going to work. It's going to cost you more in time of capacity of Lambda function or EC2 computing than what you're going to save. So what you do, that's the default, you use lifecycle rules. So you say, oh, I create a lifecycle rule that after certain amount of days is going to move my object from hot storage to colder storage. I'm moving to standard infrequent access after 30 days, after 60 days, or whatever, to Glacier, or whatever. Now, the problem is, you cannot filter objects, for example. You cannot say, oh, I'm deleting all my thumbnail or all my JPEG file after, I don't know, 60 days because I don't need them. It doesn't work like that. It's a bit like a database index. You need to have a key prefix or an object tag. So you need to think up front how you're going to put the object. So are you going to put the thumbnail under a thumbnail key that you can use as a prefix thumbnail, and anything under that prefix can be deleted after X days? Or you can tag every object when you upload them, giving a specific tag that doesn't cost, and you can use that. Or you can do a combination of both. What you cannot do is just randomly distribute the object in your bucket and then say, oh, I want to delete all the JPEG files. That doesn't work. That is quite costly. It's not going to work. Now, lifecycle rules are really great, but you really need to understand how they work because, well, this is an example. The headline is a bit misleading because, yes, the point here is not go and read this article. It's not that you lose 7,000K. The problem is you need to monitor. You need to monitor how they work because you might lose a few $1,000s every month or a few $100 or $10 a month and don't notice for years. Now, storage, but forget about S3. Storage about manual backups, snapshot. If you use any managed service, a simple thing that is always there is the ability to do automatic and manual backup. Think about RDS. You can create a snapshot with just an API call. You can even say automatic backup my database for the latest 35 days and go to be able to do point-in-time recovery at any time. That's great. It's one of they are the key features that makes those managed service so interesting because they have a lower cost in terms of overall management because they make it easier to manage those services from an operational point of view. The problem is try to remember to go and monitor those costs and how your logic, for example, in which table you back up, if you have databases, the databases that you can avoid backing up or logic you can avoid. Because, for example, for RDS, what they tell you in the documentation is, how much you're going to pay for backup storage. Well, there's no additional charge up to 100% of your total database storage for a region. And based on our DBA experience, we never pay. Most users don't pay for that. Well, it really depends on your use case. If you have a very heavily writing database, you might quickly end up without much visibility their side on costs that are more significant maybe than the computing cost of the database. So it might require an entire different architecture strategy for your database. So for example, if you end up with a bill of 27 terabytes of data, that is quite costly because you pay database storage cost that is significantly higher than S3 cost. So you might have a very different backup strategy when you figure out backup costs. But as well, EBS is one of the most common used component on AWS for almost a basic component because you're attached to any EC2 you're running. Default is still GP2. When you start is the SSD. It's been there for years now. It's been a very successful one, but there's now GP3. GP3 has been announced in December, latest reInvent. You can change it with the service up and running. You don't have to, you just do an API call or you just do it in the console. It takes a bit of time, but you don't have to stop the machine and need to monitor it maybe, but because the throughput goes down a bit in the meantime. But basic, you're going to save 20% on your cost and you get better baseline performances. So with a very, very few corner case exception, read a couple of articles, but then move as quickly as possible to GP3. You have no reason to stay on GP2. Main message starting from the GP2 to GP3 is things change really, really quickly in the cloud. Now, cost optimization is not something you do once, it's something you have to keep doing. Why? You have to keep up. You have to keep up because what happens is we all attend those amazing events like re:Invent that now was online, was a nice, cool video experience. You see the keynote, you see and you see people virtually clapping or fake clapping, whatever. And you say, oh, that's cool, that's a new service, that's amazing. Well, when that new service is out, your new feature is out, your deployment that until that morning was optimized, or you thought it was optimized, maybe it's not optimized anymore. There's a new feature, there's a new way to do things that might reduce cost. And usually the latest version is the cheapest one in most technology. So for example, you might need to migrate from M4 instances to M5 instances. Yes, you might go to Nitro, so you have to do some changes, but that's usually something you have to do. We say GP2 to GP3 in terms of EBS. As well, try to forget some old standard approach in terms as well of region. We used to start with the concept that, deploying Virginia if you are in the US and deploying Dublin if you are in the EU. Well, that's true by default, and that used to be the cheapest region and the region where most services are launched on day one. Now there are a few exceptions. I mean, in Europe, for many things, Stockholm, the new region in Stockholm in Northern Europe, is cheaper than Dublin. So something to consider. Encryption. So for example, databases, but that's not for just databases in general. You could not run encrypted storage on a database on a T2 micro instance. You had to do at least a T2 small. You think, well, I don't need such a small instance. Well, maybe think about doing a copy of a production database that you just need to do some queries or a staging environment, whatever you need to run some logic. You need to use a bigger instance because encryption doesn't work on this instance. On the T3, it works even on the micro instance now. So going to the latest version usually brings some new technology, but brings as well some cost saving. And it's pretty hard not justified not to do it. Now, why? That's the final question, really. You might say, well, it's not really my business. My business is to develop. Is cost optimization something for someone else? Is for my CFO. Well, maybe it was true in the past. If you think about your data center, the idea was, yeah, you have some fixed capacity. Usually you buy in advance, so you have a lot of spare capacity there, hopefully, for your growing project. So at the end, even if you optimize my deployment, there's real no saving today. I mean, I'm postponing the moment we need to buy new capacity, and that's cool. Or maybe I have to act because I've reached maximum capacity and my system is going to crash because I have too many users and it doesn't. So at that point, I find the bugs and I address them. But I will say in the cloud, developing without having a high on the cost is in some way too easy. I mean, if the only limit you have in your capacity is to just the credit card or bank account of your company, because the resources are, in terms of AWS, are almost unlimited. So scaling up without having an eye on the cost or without any logic on the cost is in some sense from a developer even too easy. I mean, that's where's the challenge. What you need to do is develop in a cost-efficient way. And that as well bring other effects I noticed recently as well. There's as well, you can use as well some third-party tools that's interesting as now as well the correlation you have about the carbon footprint for your company and your cloud deployment and your cost on the cloud. So there are many ways to tackle the problem from different perspectives. But at the end of the day, I will say, no, it's not out of scope for a developer to think about the cost. So go back to the first step, enable any dashboard you can have on the cost, keep an eye on that one and start from that and start to optimize anything you can and keep doing that. With that one, thank you. And I'm now open for question. So back here. I don't find any question yet here. So Yeah. So if you have any question, anyway, my email is there. You can contact me on the website or LinkedIn or wherever you want. And yeah, enjoy the rest of the day, and thank you.